Hello, my students. Welcome back into my channel. In this video, our lesson is about how we're solving a past paper, physics past paper from Cambridge IGCSE. Past paper 4, theory extended, number 062541, October, November 2023. Let's start with number 1. Number 1, a girl holds a rubber ball out of a window of a tall building. The mass of the ball is 0.20 kg. The ball is at rest 10 meters above a concrete path. Calculate the gravitational potential energy of the ball relative to the concrete path. I'm going to use in another, a different color. Okay, right. Calculate the gravitational potential energy. Its formula is 1 P equals M times G times H. M is this one, 0.20 kg. G is gravitational force, 9.8 Newton per kilograms. Okay, according to this information, this one. Okay, so it means 0.20 times 9.8 times 10, and it becomes 19.6 joule, or approximately being 20 joules. So the answer is 20 joules. The girl releases the ball. Okay, this is the picture. And it falls towards the path. This is the path. The ball strikes the path and bounces vertically upwards. So it bounces, okay, from this point. It bounces. Okay. Figure 1.1 shows the ball falling towards the path. Okay. 10 meters is the height. The speed of the ball immediately before it strikes the path is 14 meters per second. So the velocity or the speed uh, towards to this path is 14 meters per second. And the speed of the ball immediately after it strikes the path is 12 meters per second. So the velocity to upwards is 12 meters per second. Okay, so the ball falls down to until to this path, and after that bounces, and the velocity to upwards is 12 meters per second. So decrease from 14 becomes 12. Question: calculate the kinetic energy of the ball immediately after it strikes the concrete path. After it strikes the concrete path, the velocity is 12 meters per second. So we will using the velocity 12, right? To calculate the kinetic energy, the formula is 1 half mv squared. Half times 0.20 times velocity is 12 squared. So you're gonna have the solutions or the number is 14 joules. So the answer here, the kinetic energy is 14 joules. Show that the change in momentum of the ball when it bounces off the path is 5.2 kg meter per second. All right. Momentum, okay. Momentum or the symbol is P is m times delta V because the velocity changing from 14 to 12, from 14, yeah, from 14 to 12. So we can calculate the mass is 0.2 and then the velocity 14 um, minus 12 because the direction to upwards, the direction is opposite with 14. Okay, 14 directions to downwards while 12 like 12 to upwards the direction. So it's being negative. So that's 0.2 times 26. And it is 5.2 kg meter per second, like this. Okay. The ball is contact with the path for 0.25 seconds. Okay. So when this ball strike the path, the ball has time here 0.25 seconds. After that, it bounces to upwards. Calculate the average resultant force on the ball when it is contact with the path. So the formula force equals delta P over delta T. Delta P, this is momentum, which we already calculate here on part 2. So this is delta P, okay, momentum. Okay, so the force equals 5.2 over 0.25. This one, 0.25. And if you calculate, the result is 20.8 or 20.8 newtons or approximately being 21 newtons. So this 21 newton. Number 2, a copper cooking pan contains water like on figure 2.1. Figure 2.1 shows the pan on a hot plate of a cooker. Okay. Copper is a metal. Yeah, of course. Thermal energy is conducted through all solids by lattice vibrations. Okay. So it vibrating. Describe one other way in which thermal energy is conducted through the copper. Okay. So conduction actually, yeah, there conduction is actually happening on solid object, while convection happening on liquid and gas, and radiations happening on vacuum space. So this phenomenon is is conduction. So through thermal, wait, I'm going to write down my answer. Through a thermal conduction, electron transfer energy. Okay, from higher temperature area, from higher temperature area to lower temperature area. Yeah. So yeah, yeah. So from it's from the hot plate, from the hot plate, this one, from the hot plate to the copper cooking pan. So the electron transfer from this, uh, you know, from this hot plate, it's transferred. Okay, this it's moved the electron from the higher temperature from the hot plate to this cooking pan. Yeah, this copper, this metal. Okay. B. The outside surface of the cooking pan is kept clean by regular polishing. Explain one advantage of keeping the surface of the pan shiny. Right? If shiny, yeah, what the advantage? Okay. If yeah, if without carbon layers, because if not, if the surface of this pan full with carbon layers, yeah, if without carbon layers, uh, if without carbon layers covering the pan, I mean, uh, it reduce the shiny, I mean the condition, the pen shiny, reduce energy loss. Like from the pen or Cooper. Okay, so if you look your pen like this on your house, usually the pen full with carbon layers. Okay, and the carbon layers are covering this pen surface. So actually, uh, it implicated to the energy uh, to make this pen yeah, to make this pen receive energy. Okay, so if the pen surface is shiny, it will be it will be lost energy. It will reduce energy lost from the pen or Cooper. So, therefore, the surface of the pen should be shiny. Yeah, it's better rather than uh, the surface of the pen full with carbon layers. Okay. See, the thermal energy passes into the water through the base of the pen. Identify the main method by which the thermal energy is transferred throughout the water. Okay, so the answer is convection. So it's convection because convection is happening on liquid and gas. Yeah. Next, number three. Liquids are difficult to compress, whereas gases can be compressed easily. Part A explain in terms of particles why it is difficult to compress liquids. Okay, because yeah, it is because it is because the interparticle it's because the interparticle space present okay, between uh, the space present the space between the particle. Yeah. In gases, I'm going to continue here. In gases, the interparticle space, the interparticle space is very large. Yeah, in gases, different with solid or liquid, and and the and the particle are compressible. Yeah, are compressible. But in case of liquids, in case of liquids, which particle are more close. Okay, are more close rather than gas. Are more close to one another, to uh, to each other, and difficult to compress. Okay, to compress. Okay. So difference between gas and liquid. Part B, sorry, to compress. Next, part B. Figure 3.1 shows a rectangular block floating in water. The density of water is this one. Density symbol is rho. Okay. What else? This rectangular block. Okay. And yeah, from the base to the surface is 0.087 meters. This is the base of this block. The area of the base of the block is 0.014 meters squared. The base of the block is at a depth of 0.087 meters below the surface of the water. Okay. Show that the pressure due to the water at the base of the block is approximately 850 Pascal. All right. So the formula is delta P, or pressure changing, is rho times G times delta H. Okay. So rho is 1000, and then gravitational force is 9.8, while this one is 0.087. So it will be 852.6 Pascal, or you can approximately being 850 Pascal. So prove. Yeah. Calculate the force F on the base of the block caused by the pressure given in B1. So by the pressure, if it has a pressure on this area, okay, we can calculate the force. The force inside the water because of this pressure, the water pressure. So how to calculate uh, the force? We're going to using this formula. Pressure equals force over surface area. P is pressure inside the water or under the water on base. This is the pressure on base area. So this formula, if F the subject, it will be force equals P times A. Okay. So force equals 850 times 0.0. Wait, what is one? This is the base area of this base. Yeah, because this is a block, and the block base area is 0.014 meter square. 0.014. So it is 11.9 Newton. So you can approximately being 12 newtons. It is 12 newtons. Part 3, force F is equal to the weight of the block. Calculate the mass of the block. Okay, I will using this formula. Weight equals M times G, mass times gravitational force, or as well force equals M times gravitational force. So through this formula, okay, through this formula, we can state that if M the subject, M equals F over G, force over gravitational force. Okay, so it means M equals 12 newtons from this one F over 9.8. 9.8 Newton per kilogram. So it becomes if you divide, you calculate, it's going to be 1.2 kilograms. So the mass is 1.2 kilograms. Or a radio transmitter is very tall, thin cylinder. It is prevented from falling over by wires which have one end fixed to the transmitter and the other end fixed in the ground. The ends of the wires in the ground are a long distance from the transmitter. So this is the transmitter position. The transmitter hold by two wires, okay, from the ground into this point. And next figure 4.1 shows the transmitter and two of the wires. So these are the wires. It's the base and this is the point G. This is the transmitter position at the upwards. Right. Figure 1.4. The center of gravity G is shown on the figure 4.1. This uh, the center point. Right. State what is meant by center of gravity. What is mean this G? Right. So on this point G, the radio transmitter on the position balance. Okay. So its positions is balance of the radio transmitter. Okay. Radio transmitter of from this is the base of the radio transmitter and the top of radio transmitter here and the balance positions here on G point. So the center of gravity uh, mean yeah I'm going to writing a point where entire weight of an object can be considered to act. Okay. Yeah. So I'm gonna add, yeah, it is a point. It it is a point. It's a point through uh through it's a point through which the force it is a point through which the force of gravity acting. think this is enough. Explain why the radio transmitter without the wires is a very unstable structure. Yeah, also it should hold by two wires. Okay. Why? Because the radio transmitter center of gravity because the radio transmitter of gravity, yeah, is high. Is high above the base. The base. Uh, then, okay, sorry. Then a small, then a small tilt makes center of gravity no longer, okay, no longer vertically. Wait, I'm going to erase this one first because I will writing here vertically, yeah, vertical above the base, above the base. Okay. So, uh, yeah, it needs wires. So it needs wires, uh, this wire and this wire to hold this transmitter. If without wire, its position is unbalanced. Wire W is under tension and it exerts a force T on the transmitter. Okay, but on figure 4.1, mark an arrow to show the force T exerted by wire W on the transmitter. So we're going to mark with arrows to show the force. So the force acting on this wire is, so the force acting on this wire and the force direction to downwards, okay, to the ground. Yeah. What else? The force T produces a moment on the transmitter about its base. Describe how the moment produced by T is calculated and indicate on figure 4.1 what is meant by any other terms on the descriptions. Okay, so like if you look this, that uh this is, okay, yeah, so the moment is F times D. Yeah, moment F times D, the force times uh the distance, okay, the force direction to the ground, and this the distance. So the F times T force times D is the moment. This, yeah, so if I will answer this, so moment equals 4 force times D. Yeah, force, because from the gravitational force from the G point to downwards, and the distance is that's is if you want to calculate the moment. The radio transmitter uses radio waves to transmit radio and television programs. State one other use of radio waves. Oh yeah. Uh, I will answer this. For example, Bluetooth. Yeah, for Bluetooth. Yeah, this. Yeah, only one. Number five, many methods of generating electrical power involve the use of water. Question A, describe one method of generating electrical power from energy stored in water. My answer is hydroelectric power. Hydroelectric power. Okay. Hydroelectric power, of course, in turbine, because it is produced, yeah, it is produced, it's produced, yeah, with, it's produced not with, but through moving water. B, for the method you choose in A, okay, state one advantage and one disadvantage of generating electricity this way. The advantage is it is provide, sorry, yeah, it is provide low cost, low cost electricity. Yeah, it is provide low cost electricity, and yeah, and durability, I think. Yeah, yeah. This provide low cost electricity and durability over time. That is the advantage. So how about disadvantage? Disadvantage, yeah, it has float, yeah, it has float risk. Yeah. It has float risk for area around it around the hydroelectric power, around the turbine. C. State two methods of generating electrical power for which the main source of energy is not the sun. Yeah, through geothermal energy, and the second through nuclear energy. Yeah, that's one. Number six, a page of printed text is placed 18 centimeters from a converging lens. Okay, this is an object 18 centimeters from the converging lens. From a converging lens of focal length 35 centimeters. So the focal length 35 centimeters, as well this focal length 35 centimeters. Figure 6.1 is a scale diagram of the arrangement with each of the two principal focal points of the lens labeled F. Right. After that, the question, a length of 1 centimeters on the scale diagram represents an actual length of 5 centimeters. So it's 5 centimeters. It means and each block is 1 centimeter. Okay. Part A. Part A1. By drawing on figure 1.6, locate the image of the page produced by the lens and label it I. Using figure 6.1, determine the actual distance of the image I from the lens. Okay. The first step, I will sketch the straight line from this object to this lens, and then I will to be this one just now. After that, the straight line through focal length, and then wait. Okay, that's one. Should be precise to point here. And the second straight line, okay, okay, and okay, that's one. Yep. So the image, so this is position here. Okay. Right. Okay, yeah, like this. The image now the image is from the color. This color blue. I wait. Sorry. Okay, this is the image. I have to expand until here. Okay. Okay, that's the image. This the part one already, and label I. Okay, I'm going to label it as I. This is I. Wait. I. And then part two, question two is using figure 6.1 determine the actual distance. Actual distance, this is 6. Sorry, not 6, 18 centimeters. Wait, 18 centimeters from this line to this line. Okay, 18. And if we measuring this is 18 as well. So okay, yeah, 18 centimeters, and it is 18 centimeters. So it becomes, wait, 18, 18 plus 18 is 36. Okay, 36, around 35, 38, around 38.5. So the actual distance is 38, sorry, 38, sorry, oh, wait, 38, 38.5 centimeters. Question B, converging lens can be used as magnifying glasses. Okay. State whether the image produced when a lens is used as a magnifying glasses is real or virtual. Of course, virtual. Explain why. Because the image, because the image, yeah, because the image should be projected, okay, be projected on the screen. As you know, the area upwards of this uh, upwards area is area for the real area or for a projector area. Meanwhile, the area under the strike line is area for virtual area. suggests how someone who is long-sighted may benefit from using a converging lens. Yeah, if someone, wait, so if someone who is long-sighted, if someone who is long-sighted uses a converging lens, it reduces, yeah, it reduces focal length. It reduces focal length. So the image, yeah, the image will be fall, yeah, will be fall on the eye, on retina, on retina. Okay. Number 7, a plastic road is uncharged. When the road is wrapped with woolen cloth, the road becomes negatively charged. Explain in terms of particles why the road becomes negatively charged. Yeah, uh, because the electron from woolen clothes moving to the plastic road, and therefore the plastic road will have the negatively charged. So my answer is because electrons the woolen from the woolen cloth, sorry, from the woolen cloth moving moving uh, to the plastic road. So the plastic road becomes negatively charged. Okay. Figure 7.1 shows a negatively charged metal sphere S. Okay. There is an electric field surrounding S. Okay. State what is meant by an electric field. Electric field is the area or region where the electric charge experiences a force. On figure 7.1, draw the patterns of the electric field surrounding sphere S and indicate its direction. So the electric field that is, and the two. That's fair. Okay. Its charge is positively charged. Figure 7.2 shows a small negative charge Z placed near to sphere S. This one. Charge Z experiences a force due to the electric field surrounding S. Okay. On figure 7.2, draw an arrow to show the directions of this force on Z. Of course, this charge will be away from sphere S. So the direction like this. Yeah. Because around of sphere S there are positively charged. Yeah. Eight, a cylinder is made of modeling clay. The modeling clay is an electrical conductor. Figure 8.1 shows the cylinder. This one. This is the cross-sectional area. And then, wait, okay. The cylinder is connected into a circuit. Figure 8.2 shows that the circuit also includes a battery of electromotive force 9 volts. So then electromotive force of this battery is 9 volts. And a resistor P. This is the resistor in a circuit with cylinder of modeling clay attached on the circuit. The resistance of P is 4 ohms and the current in P is 1.5 amps. Calculate the magnitude X of the charge that flows through P in 600 seconds. Right. So to calculate it, we're going to using that for the formula that, as you know, that I'm going to using the formula Q equals I times T. Yeah, which I is 1.5 amps and T is 600 seconds. And the answer is 900 coulombs. So X equals 900 coulombs. The resistance of the cylinder of modeling clay. We have to calculate part one is the Q charge of X, and part two is the resistance of the cylinder, resistance of this resistor. Okay. To determine the resistance, I'm going to start from this formula that potential difference equals electricity current times electricity times charge, the object charge. So if R the subject, this formula being phi over IR equals phi over I. So we can determine the resistance through these calculations. Phi is 9 volts over 1.5 amps, and it is 6 ohms. This is the resistance for that circuit. And We're going to determine the resistance of cylinder. The resistance of cylinder is 6 ohms minus 4 ohms. And this is the resistance uh, of resistor. So it's going to be 2 ohms. So 2 ohms. The cylinder is removed from the circuit, or it's removed and replaced with a new cylinder. The new cylinder made of the same modeling clay, made of the same material. The new cylinder is twice the length and has half okay, the cross-sectional area okay, of the first cylinder. So its area half of the first cylinder. Calculate the time. We will determine the time that it now takes for a charge of magnitude x to flow through resistor P. Right. I will start from a resistance of a new cylinder. I'm going to determine the resistance of new cylinder. The resistance of a new cylinder, uh, as you know, that if one cylinder, 2 ohms, according to this information, that is twice length. Yeah. So the length is twice than this one, the first cylinder. So it means uh, the charge, the resistance will be 4 ohms. But uh, the area of the second cylinder or the new cylinder is half of the cross-sectional area of the first cylinder. So it means we have to divide it by half, and it becomes 4 ohms times 2. 8 equals 8 ohms. This is 2. Sorry. Yeah, 8 ohms. So the resistance of new cylinder is 8 ohms. So total resistance on a circuit is 8 ohms plus 4 ohms. Yeah. This is the resistance of a resistor. So it becomes 12 ohms. Next. We will determine times according to this formula. And how to determine time? I will using this formula T equals Q over I. But we have no information regarding I. If Q is 900 coulomb, Q this one. Okay. And I, we have no information. So it means we have to calculate I first. Based on the formula that I, we can determine through this formula, I equals V over R. And just now, this one. Just now, we already determined R through this formula. So if I is the subject, this formula being V over R. This one. So it means I equals V is 9 volts and R is 12 ohms, this one. So it becomes 0.75 amps. Okay, So we can calculate T equals 900 coulomb over 0.75 amps. And it is 1,200 seconds. So the answer here, the time is 1,200 seconds. Number 9, many household smoke alarms contain a sample of the radioactive isotope americium-241. Americium-241 is the isotope of the element americium that has the nucleon number 241. State how the compositions of the nucleus of americium-241 differs from that of the nucleus of americium-241. If you compare this americium 241, yeah, it has total neutron. Yeah, if you compare then americium 242, yeah, it has total neutron less one in its nucleus. Yeah. Part two, an atom of a different element has a nuclear number of 241. State two differences between the compositions of a nucleus of this atom and a nucleus of americium 241. So in a nucleus, yeah, in a nucleus, in a nucleus, it has different number is different number of protons and neutrons. Yeah, that's the difference. Americium-241 decays to an isotope of neptunium by alpha decay, alpha particle emission. Complete the equation for this decay. If 241, it means this is yeah, this is 4. It means this is 237 because 237 plus 4 equals 241. And if this is 93, that alpha particle emission, this is 2. That means this is 95. Right. One reason for using an isotope that emits alpha particles in smoke detectors is that the particles are more strongly ionizing than beta particles. So explain why alpha particles are more strongly ionizing than beta particles. Because alpha particle because alpha particles have more kinetic energy. It has more kinetic energy rather than rather than beta particles. Number three, the isotope of neptunium produced by americium-241 is also radioactive. The decay is the decay of this isotope of neptunium produces an isotope of protactinium, which decays by beta emission. Beta particles are more penetrating rather than alpha particles. The half-life of neptunium is longer than 2 million years. Using this information, explain the advantage of this long half-life for the use and safe disposal of a household smoke alarm. So it has it has few emissions per unit times. It has few emissions per unit time. So so the smoke detectors so the smoke detectors the detectors are not the smoke detectors uh, are not hazard for the humans. One, 10. The Milky Way is one of many billions of galaxies. Yeah, so our Milky Way is one of billion galaxies. So there are lots of galaxies, not only our Milky Way. Each galaxy contains many billions of stable stars. Stable stars transfer energy into space by emitting electromagnetic radiation from their surfaces. Describe what happens in the core of a stable star to release energy that is eventually transferred into space. So hydrogen nuclei on the star fuse become helium nuclei. Helium nuclei. Or you can answer that hydrogen fuses being helium, or hydrogen fuses into helium. On the Earth, light from a distant galaxy is observed and analyzed by astronomers. This information is used to determine the speed at which the galaxy is moving away from the Earth. Describe how the observed light is different from when it was emitted. The wavelength, I'm going to answer that. The wavelength is longer, so the light, so the light is is shifted towards towards the red end of the spectrum. Uh, State the quantity that astronomers use to determine the speed at which the galaxy is moving away. Yeah, change in wavelength. In wavelength. The Hubble constant H0 is equal to 2.2 times 10 power minus 18 per second. Calculate the distance from the Earth of a galaxy that is moving away at a speed of 1.3 times 10 power 7 meter per second. We can calculate distance through its formula that distance equals velocity or speed over h0. So it is 1.3 times 7 times 10 power 7 over 2.2 times 10 power minus 18. And the result is 0.59 times 10 power 25 meters. And it is, you can writing as 5.9 times 10 power 24 meters. The answer here, 5.9 times 10 power 24 meters. Calculate an estimate for the age of the universe. Give your answer in years. Age of universe, age of this universe equals 1 over h0. So it is 1 over 2.2 times 10 power minus 18. And the result is 0.45 times 10 power positive 18 seconds. Or we can writing as 4.5 times 10 power 17 seconds. But the answer should be in years. So we have to convert second into years. 1 second, I'm going to write here 1 second equals 1 over, yeah, in years. 1 year is 360 days. 1 day, 1 day is 24 hours. 1 hour is 60 minutes. 1 minute is 60 seconds. So if you calculate this number times 1 over 360 times 24 times 60 times 60, you will find a number 1.4 times 10 power 10. And this is the result. Okay. Students, thank you for joining with me in this lesson. If you have any questions, you may email me. Thank you. See you.